SS3 students, in continuation of our online revision for your exams, we're going to look at probability. I know in one stage of your life, you must have involved in trial luck. You may try to know whether you will be a lucky person to win a particular thing. So you are not sure. Many people are involved, including yourself. So you are not sure of winning, but you can try a luck. So also in mathematics, you have a topic that deals on this trial luck, which we call probability. We have experimental probability and have laws of probability. We're going to have each of them, I'm not teaching it. We're going to revise. I'll revise with so many past questions, but we don't have the idea first. Probability has a definition. To guide us. Definition is that P stands for probability, and we define it as the ratio of number of required outcome. The ratio of number of required outcome to number of possible outcome. With this, we are going to handle all cases of probability. Let us try a simple one. You see it in your OBJ, mathematics. Supposing you are asked to say, find the probability. The probability of picking a letter I in the word probability. Find probability of picking a letter I in the word probability. Find probability means how many chances do you have of picking a letter I. Assuming that in a bag, the word probability, all the letters are involved there. So how do you answer it? You just say probability P, that probability of picking I equals, so brackets indicates what you are looking for. Now, you have to go to the word probability and know how many letters are there. If you count with me, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Probability. You have 11 letters. So you have 11 chances of picking the letter. So once, if you line 11 students, each must pick a letter. But when you have the 12 students, you cannot pick a letter. So you have 11 chances of picking a letter. So that is number of possible outcome is 11. Then, what letter do you want? Maybe if you're able to pick I, the school money may give you a scholarship. So how many people will be able to pick I? That's what I'm talking about. Required outcome. If you go to probability, you have I occurs only in two places. Probability. So you have two chances of picking letter I. So out of 11 students that we vie for the management scholarship, only 2 people will get scholarship out of 11. That 2 of 11, the probability of picking the letter I. That's very simple. That's very simple. So you use it and carry out so many things. For example, before I continue, when an event has either it has 2 chances of occurring, probability is half. Is half. In a day, either it rains or it may not rain. So probability of raining or not raining is half. But when the probability is when you are sure, it is 1. When you are sure, and who is going to be sure is only God. Only God. So human being cannot be 100% sure. So the highest you can talk about is half. That a woman that is pregnant will born either a baby boy or a baby girl is half. He must born. Then it is only God who says it must be a baby boy. No matter nowadays, we talk about they go for scanning, they will tell you it's boy. Sometimes it fails. So I move on. As when you talk about a coin. When you throw a coin, I don't know what the coin is because we are talking about notes, naira notes. But before the war, you have a coin, 1 shilling, 2 shillings. Listen, if you throw the coin, maybe observe them when they are playing football. They use coin to decide those who take this post or which side will kick first. When you throw a coin will either fall head or tail. Coin will either fall head or tail. So that the coin will fall head is half. If it fall tail is what to half. So probability of a coin falling head or tail is half. That's one of the simple things they will ask you. But when you produce further, you can have laws of handling it. Let me now talk about if you have 2 coins, say 3 coins. So here you can list out the possible outcome. But when you want to solve, you may not list. But when the number of coins increases, you want to list, cannot list it. You may stay in that position, the time will be okay. But for these 3 coins, it doesn't fall head. All of them might fall head. They may fall head, tail, head. They may fall head, tail. They may fall tail. So you see, they may fall tail, head. And lots of them can list it. But since you cannot list all of them, you have a simple formula to get it. The formula is 2 raised to the power n. 2 raised to the power n will give you the total outcome the coin will fall. Then after that, when you have known the total outcome, the next thing is which one do you require. So the possible outcome, if you talk about 3 coins, it will be 2 raised to the power 3. We're going to give you 2 times 2 times 2. To give you 2 times 2 is 4, which is 8 outcomes. So let us now see it now. 1, 2, 3, 4, 5. You have tail, head. That is 1, 2, 3, 4, 5, 6. You have tail, head. 7. And you have what? Let's take it coolly now. Have the head, tail. Head, tail, tail, tail. 1, 2, 3, 4, 5, 6, 7. It means 1. We're going to get it. head, head, head. Let me finish with head. Head, head, tail. Head, tail, tail. What again? Talk about tail, head, head. Okay. Now we finish with tail. Now tail, tail, tail. Tail, head, tail. Tail, tail, head. Head, tail. Okay, that one. 1, 2, 3, 4, 5, 6, 7, 7. What is missing? Okay. Tail, 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 head. I'm going to give you 8. But that is for elementary. The best way is to use the formula. Then assuming you are out to find probability. That's number 1. Find probability. Find the P. 2 tails. 2 tails. 3. P. Tail. 2 tails and head. P. A tail and 2 heads and the rest. Now, tail and the head. You hear? Tail and the head. Tail and the head. No, 2 tails and the head. It's about 2 tails. First one, 2 tails and the head. 2 tails. Just move in here. Another place. Here. 2 tails and the head. Now we'll come up here. Give you 1, 2, 3. So the give you 3/8. A tail and a head. A tail and a head. 1, 2, 2. So only 2. 2/8. What's 1/4? These are elementary probability. 1 will give us thinking. Before we go there, let us discuss the laws of probability. Laws of probability. We have 2 laws of probability. We have what we call addition law. Addition law. You can state it. I don't think they have to state it in the exam, but just know it. If events are mutually exclusive, total probability are added of probability of various events of the events involved. What are we saying? Look at the word mutually exclusive. What do you call mutually exclusive? Mean that one event will prevent you from getting the other. One event will prevent you from getting the other. That's the mutually exclusive. So they cannot happen either this or that. Either they will allow or they don't. You cannot be alive and dead at the same time. So these two events are mutually exclusive. Either you're a boy or a girl. Also mutually exclusive event. Sometimes you may attend a function and say, which one do you prefer? You want to swallow or rice? You cannot easily swallow and write at the same time. So I've explained mutually exclusive events. Then you add it up, which means P total equal to PA plus PB plus PC up to Pn. That's total event. N stands for total event. So that's what we call mutually exclusive. Let us go to another event, another law. Mutually independent event. Mutually independent event. You talk about multiplication law. You know, I'm not teaching this in detail. I'm just reminding you what I've done. This is SS3 work. So when you say independent, it means that you are doing that do not prevent you from doing the other. For example, it may be a greedy type. You go to an arena where the function where have so many drinks. You may decide to drink stout and then use malt to mix it. You may now give me a stout there. Give me more, then me mix it. People may be saying, you will say, if you want to drink, drink. Why are you quarreling? You have so many drinks. So they are drinking stout, will not prevent you from drinking malt. Or you go into a restaurant, and also I don't know what I use the word greedy people, but sometimes people like to play that behavior being greedy. You may tell the owner, give me soup. Which soup you have? I have a wusi. Please give me a wusi. Put a small bitterleaf there. Get me meat for stew. So we want to taste everything inside there. So nobody will prevent you from doing that. It's your money. So these events are mutually independent. That you are doing that, not prevent from doing the other. So in this case, use what we call multiplication. So here, P total is equal to PA multiplied by PB multiplied by PC up to multiplied by Pn. So I have explained the two laws. I have explained the experimental probability. Let us now go to Wire equations. Now, Wire equation where the experimental type and the law can be applied. Follow me as I give you these questions. I want us to do it very fast because time for this lesson are not rather big. This question says, a bag contains 6 red, a bag contains 6 red marbles, 4 blue marbles, one marble is drawn from the bag and replaced before second one is drawn. What is the probability that they are both blue? One is drawn, one marble is drawn and replaced before second one is drawn. So it means that 2 marbles were drawn. Now with replacement, the word with replacement. Now before I go to this question, let me tell you how to find this, how to know the law I'm using now. Once you hear either, it is addition law. Once you hear both, it's the multiplication law. So I'll show everybody now, and there's both there. I'm going to count to multiplication law. But I said either. So here, in this case, they said find probably that they are both blue. So let us now do this equation. One marble was picked and replaced before second one was picked. Then find P. So 2 marbles were picked. So find P. They are blue. They are blue. That's the first question. Second question. Let us finish the first one. So first of all, you start by saying P first. Blue equals then. Let's go back to the definition. How many marbles are there in the bag? 10. Then how many blue marbles are there? 4. Therefore, here we pick the blue marble. Therefore, picking the face to be blue is 10, 4 over 10. You see it now? 4 over 10. You have 4 chances of picking a marble out of 10 marbles. Then the next one, you replace it. The one, watch the one, replace it. That's P, second blue. The same thing, 4 over 10. Then P, both blue equals 4 over 10, both P multiplication law, multiplied by 4 over 10. That's going to give you 4 times 4 is 16, 10 times 10 is what? 100. If you leave it here, we will lose some mark, because you have to bring it to the lowest fraction. What we divide here, 4 divided 16 will give you 4. 4 divided 100 will give you 25. So the answer is 4 over 25, the square mark. Then, let me quickly handle the question not asked here, for not to be very, very fast. What about, I'm answering the same question, but here, this is with replacement. What about without replacement? Without replacement. So let us quickly do this. Do not among the question asked. Then, if you talk about without replacement, you continue with the same procedure. P first, blue equals 4 over 10, but P second blue will be equal to 3 over 9. Why 3 over 9? Why 3 over 9? You have picked the first marble and you return it, you throw it away. Therefore, total marble in the bag now will be 9. And chance of getting blue is also 3. One blue has been removed. So P, both blue, is then as P, both blue equals 4 over 10 followed by 3 over 9. 4 times 3 is 12. 9 times 10 is what? 90. How to go to the lower fraction? 3 cancel 12, 4, 3 90, 10. Go further. 2 cancel 4, 2. 2 is 5. So it is 2 over 5. Then second question says, under it, they are of different color. They are of different color. They are of different color. How do you handle this? They are of different color. Now, sometimes both multiplication law and addition law will be in one question. They are of different color. First, different color. P, different color. So what do you mean by that? Either you get P red, or you get red P. That's what it means. The first may be red, second blue. Sorry, either the first is blue, second red, or first is red, second blue. So let's handle it now. P, first red, equals how many red are there? P first red, 6 over 10, you replace. P second blue equals 4 over 10. 4 over 10. P red blue equals 6 over 10 times 4 over 10 to give you 4 times 6 is 24 over 100. Don't handle it here, don't divide yet. That is, or P first blue equals 4 over 10. P second red equals 6 over 10. P, wash it, blue, red equals 4 over 10 times 6 over 10 equals 24 over 100. Then, that's why I said, what you use here is multiplication law. But the final answer will obtain from addition law. So that is why you see or here. Either this or that. Remember I told that addition means either this or that. So P, red, blue, or blue, red. So this is going to give you 24 over 100 plus 24 over 100 to give you LCM 48 over 100. You can now divide. What can divide now? If you divide very well, you will get it 12 over 25. 12 over 25. That is it. The final one says probability of getting they are of the same color. They are of the same color. So you're going to do it. The assignment. They are of the same color. That's the P, red, red, or blue, blue. Do it. P, red, red, or blue, blue. If you look at this now, find P of first red, second red, you keep. Find P of first blue, second blue, you keep. Then find P of both. Both that means what? Addition. So I'll stop it here. Probability is a very interesting topic. And next lesson, I will be naming the years it appeared. So you should know that whatever we are doing here, we have gone through the OAM question papers and know the topics that are normally being repeated. And I'm discussing part 2 of mathematics. Part 2. If you pray very well, you enter the exam hall and happen to be able to solve 2 questions there, say bye-bye to P in mathematics. Let me start from there. Thank you very much. Next time we continue.